team gets a new LTV model. They're excited. It's got AUC 0.933. The benchmark is XG Boost churn. The paper says it's from RXI 1990469. The validation method uses HTTPS as H6904-6902. They run a test. The model picks 800 leads. They get 96 wins. The top 20% of those leads hold 64 wins. That's what they call their ratio versus random result. It looks good on paper. They take it to production. Then they look at the actual performance. The model delivers just one win, and that's it. Their model was a fraud. They never evaluated correctly. They took a model that had been trained on data with a specific holdout set and treated it as if it were validated in real production. And it wasn't. Not even close. This is Marketing Science, the show about building and evaluating data-driven marketing models. I'm Mikey, and today we're talking about how to correctly evaluate LTV models and what happens when you don't do it right. LTV evaluation isn't about the fancy metrics or the math. It's about the real-world cost of your model's mistakes. Most people treat the model as a black box and run a quick validation on their training data, assuming that's all they need. They forget the difference between holdout, production, and generalization error. And that mistake is what kills models in practice. In a typical evaluation setup, you're trying to measure how well your LTV model can predict which customers will be valuable. You start by splitting your data into training, validation, and test sets. That's standard. Then you train the model on the training set. You validate on the validation set. And then you test it in production. But here's where things go sideways. Most people don't understand what happens when they move from validation to production. The holdout dataset they use for testing may not reflect the actual data distribution that will be coming in, or they might have used a different method of evaluation than what they'll actually apply in practice. For example, say you're predicting churn using an XG Boost model trained on a historical dataset with 10,000 leads. You split the data and get your AUC at 0.933. That's great, right? But then you deploy it. You pull 800 leads from live data. Out of those 800, you get 96 wins. If the top 20% of those 96 leads hold 64 wins, your ratio versus random looks like 64 over 19.22, which is a 333% lift. But that ratio isn't what matters for production performance. In real life, you don't just take the top 20%, you run a campaign and see how many actual wins you get. If that's not what your model actually predicted, then the whole exercise was wasted. The key idea here is that model performance metrics are only meaningful if they're evaluated in a way that mimics what happens once it's live. And you must use a holdout method that reflects production realities, not some artificial test that doesn't capture how the real world behaves. So how do you build an accurate and usable evaluation setup? First, you need to clearly define your goal. Are you trying to optimize for top K wins? Or are you trying to maximize revenue per customer over time? You need to know that before you choose any metric. Then, define what win means. Is it a purchase, or is it a conversion within a specific window? Next, create a production-like test environment. That means pulling data from the same source you'll use in production, not just some random sample of past data. Use historical data that reflects the real-world distribution and seasonality. If your model is going into an online store, make sure you're testing on similar data. Then, run a holdout test, a true holdout, where you separate part of your data before any training or tuning happens. Don't let the evaluation process peak at production data. That's not just good practice, it's essential. After that, you can do the actual evaluation. Use metrics like AUC or log loss on the holdout set to get a baseline, but don't stop there. Now comes the critical part. What happens when you apply that model in real conditions? You must simulate production usage by running your model with the same filters and constraints it will face live. You need to measure performance not just in terms of hits, but in terms of actual business impact. For instance, if the top 20% of leads from a test produce 64 wins out of 96 total, that's a strong signal. But if you only get one win when you run it live, there's a mismatch between your model and your data pipeline. So what do? You must recheck, not just the model, but how it's applied. Did you make assumptions about customer behavior or data quality that weren't true in production? That brings us to the one rule that matters. If you want to build a good LTV evaluation system, always validate your model in a production-like holdout. The moment you let that line of reasoning go, your model becomes a guess, not a tool. The math is simple. If you're using AUC or another metric to evaluate and then deploy in a real environment without validating it against actual production data, you're gambling with your marketing budget. You're not just making a mistake, you're misallocating resources and losing business. So always remember, you don't measure a model on its performance alone. You measure it on how well it performs when it matters. Now, the mistakes people make here are more than just technical errors. They are systemic issues. The first mistake is assuming that validation in one environment equals production readiness. If you train on past data and test on a different set of users, and then deploy on live customers without verifying how it works in that real-world context, your model will fail in practice. Second, people skip the evaluation of business impact. They care about AUC or lift, but not how many wins or revenue they actually get from deploying the model. Third, they rely on a single metric to judge success. If they only measure AUC and ignore things like precision or recall, or worse, don't even calculate what happens when they apply their model in production, they're blind. Fourth, people ignore the feedback loop between model performance and data drift. As time passes, new patterns may emerge that your model didn't see during training. Without periodic evaluation of performance in production, you'll keep using outdated models without knowing it. And fifth, many teams fail to define what success looks like before building a model. They start coding, then wonder why the results don't match their goals. That's not just bad design, it's bad planning. If you're not asking these questions early and often, your model will be fine in theory, but terrible in practice. LTV evaluation is about more than numbers. It's about making sure that the model you deploy actually works when it counts. The way you measure it has to match how you'll use it. If not, you're just throwing money at guesses. Do that right, and you get a system where you can trust your predictions. You get models that improve over time instead of degrade. That's how marketing science becomes real. If this one earned its time, the full course is inside the marketing science course at learn.mikey.ai. I'm Mikey. Go evaluate your model now.